1950s, when this car was designed, Rolls-Royce was also the world leader in jet engines for aeroplanes. Since then, a lot of air miles have been clocked up. Today, Rolls-Royce Aerospace is a completely different company from the car maker, and they now face tough competition from two other big jet engine manufacturers, fighting to win orders for the next generation of airliners. For the sole UK player, it's important not to be overtaken. The trouble is, the other two main contenders are American, and that gives them an enormous advantage. It's called NASA. The government-funded agency doesn't just do space research, it also gives a lot of free help to US engine companies. The British company has to pay for most of the basic research itself. Despite that handicap, Rolls-Royce Aerospace must make a success of their new jet engine if they, and part of our heritage, are to survive. The engine, it's called the Trent, is currently undergoing crucial trials at a testing ground in Derbyshire. So, what's it got going for it? Well, first of all, a bit of background. All jet engines work on the same principle. Air is sucked into the engine through the front, it's compressed, mixed with fuel and ignited, and then it's blasted out of the back. To be successful, a new engine must do all that more efficiently, more powerfully, more reliably, and believe it or not, more quietly than its rivals.
It's on condition.
Power tests must confirm that the Trent can deliver up to 100,000 pounds of thrust. Its technology borrows some ideas from its smaller predecessor, the RB211, ideas still unique to British design. The first difference between the Trent and its American rivals comes right at the front end, the blades that suck the air in. This is a cross-section of a Trent blade. The hollow spaces allow it to be very light, but still being strong enough to withstand anything being sucked into the engine. Such as hailstones. If I was flying, I'd certainly be glad to know that the engines could survive a hailstorm. Another special feature of the British design is that it's got 3 separate shafts to drive the different parts of the engine, instead of the more usual 2. This allows each stage of the engine to run at its most efficient speed. And it's also lighter, and with a lighter engine, the aeroplane uses less fuel. But there's also another factor. The latest buzzword in aviation is NOx, N-O-X. It means oxides of nitrogen, the most polluting of the exhaust gases. And they're testing for that today. Now, all this in here may look a bit Heath Robinson, but right in there, they're testing the latest adaptations to the Trent combustor to ensure that the NOx levels fall within international standards. The fumes from the engine are measured in an emissions van.
We'll be on the next condition shortly. We can probably take the sample now, actually. The NOx is low, 15 parts per million. On-board fuel 6.
But one American company, General Electric's, gone even further. They've completely redesigned their engine. It'll have 2 combustors, 2 places where the bang happens. By doing this, they claim to have cut to a quarter their NOx emissions. But the more radical the change, the more likely there'll be teething problems with their engine. In sticking to a more conventional engine layout, Rolls-Royce reckon they'll have an edge in the market when it comes to reliability. When you buy a new car, you can usually choose which engine version you want. The same goes for an airline buying its planes. If enough airlines choose the Trent, then a large chunk of the British jet industry is secure. Mind you, without an organisation like NASA as backup, it'll always be a tough struggle.